Today we will do logarithmic equations, part 1. Okay, so first off, a logarithmic equation is one that includes one or more logs involving a variable. Okay, so essentially you have log and an equal sign. Okay, now our steps in doing a logarithmic equation, first thing we'll do is we'll write it in exponential form. Okay, so in our case, if there is no base, remember we assume base 10. And when we write in exponential form, we always start at the base of the log. So 10 across the equal sign to the second power equals 5x plus 2. Now, our next step is just simply to solve for x. So we know we have 100 equals 5x plus 2. When we subtract 2, we'll have 98 equals 5x. And when we divide by 5, we get x equals 98 over 5. Our last step is to check for extraneous solutions. Remember, we cannot take a negative log, so we just have to ask ourselves, if we plug 98 over 5 back into the original equation, will we get a negative log? And the answer to that is no, so we are good to go. I want you to try the example you tried. This one was a little trickier in regards to we had a negative exponent. So remember, when you have a negative exponent, it just moves to the denominator of that fraction. When you subtract 3 on both sides, isn't 30 over 10 the same thing as 3? Yes. So now we have fractions with like denominators, and we just subtract the numerators. So we know 1 minus 30 is negative 29. So negative 29 over 10 equals negative 2x. When you divide by 2, that's really multiplying by 1/2, and we do get x equals negative 29 over 20. Okay, so if we look at the next type of problem, notice we have other numbers on the same side as the logarithm. So the first thing we're going to do is we're going to isolate the log. So we'll subtract 6. So 2 log base 9 of x equals 1. And then we'll divide by 2. So log base 9 of x equals 1/2. And then we'll write it in exponential form. So we always start at the base of the log, go across the equal sign, and end what we're taking the log of. So 9 to the 1/2 power equals x. And remember, when you solve by square roots, technically you have 2 answers, right? So this is the same thing as x is equal to the square root of 9, which is plus or minus 3. But can you put both a positive and a negative in for that x? We can do positive 3, but remember, you cannot take a negative log. So our actual only answer is x equals 3. Take a minute and try the example you tried. If we look at this next problem, hopefully you found e to the 10 over 3 power equals x, and when you type that into a calculator, exactly like you see, you do get around 28.032. Let's look at another one. So, first thing, is the log isolated? Yes. What is the base of natural log? E. Okay, so all we do is we write it in exponential form. So e to the 3rd power equals the square root of x plus 6. Well, how do you get rid of the square root? What is the opposite of that? And hopefully we recognize, oh, it's just squared. So remember, when you have a power to a power, you multiply the powers. So e to the 6th power equals x plus 6. Now, to solve for x, you subtract 6. So we'll have x equals e to the 6th minus 6, which is, the exact form. And if you type this into a calculator, you do get around 397.429. Take a minute and try the example you tried. And hopefully for this one, you do get x equals 69. Once we write it in exponential form, it becomes an equation that we solved earlier in this unit. Here is our last type of problem. First question, is the natural log isolated? Yes. And this one is kind of tricky too, because if you recognize the base of natural log is e, guess what? your left side is already just x plus 6, and that equals 4. And so all you do is you subtract 6, and you get x equals negative 2, which, if you plug negative 2 back in for this x, you don't get a negative exponent. So we are good. Try this last example you tried. Hopefully on this one you recognize the base of common log is just 10, and so right away we're just left with x minus 2 on the left side of the equation. And you get x equals 7. The end. Yay, we can try some practice. The end.